This project demonstrates the usage of Gemini LLM for analysis and comparison of annual reports of public companies. This kind of analysis may be an important but time-consuming task for investment managers. In particular, the volume of such documents is usually quite large. The number of companies under consideration may be large. Reports are published synchronously once a year. So this solution demonstrates how Gemini LLM may be used for analysis of annual reports and why it's important to have a large context window for this kind of tasks. There are several examples in each of which two annual reports are compared. The summary of this comparative analysis is presented in a condensed, convenient format. In the first example, there are two reports of the same corporation for 2 consecutive years. So the goal of the analysis is to demonstrate the dynamics of changes in the company. The following examples are based on reports from different companies in the same industry. One example shows a direct comparison of 2 companies. And the final example demonstrates the scenario in which caching of one of the reports is used. Now let's examine the implementation. Preparatory steps include model initialization and loading of an input dataset containing 2 annual reports of a given company. The main prompt describes the requirements for analyzing the input reports and displaying the output. As we can see, the total token count for this operation exceeds 200,000. Here we can see that the model produces a markdown table in accordance with the requirements and based on the content of the input reports. So this is the main output that is potentially valuable to end users such as stock analysts. Now let's move on to the second use case. In this example, the comparative analysis of annual reports of 2 different companies is demonstrated. The overall approach is similar to the first use case. 2 annual reports are loaded, and the corresponding prompt is used for comparative analysis of the companies. The results are similar to what was demonstrated before. The total number of tokens exceeds 200,000, and the output summary table is based on the information from both input reports. The final example demonstrates how caching may be used for such tasks. There may be a situation where a particular company publishes its annual report, number 3 on this diagram. This report should be compared with several reports published by other companies earlier in this reporting season, number 1 and 2 here. So in this example, number 3 will be cached because it is involved in 2 comparison operations that should be performed practically in parallel. In this scenario, model initialization includes the creation of a cache that contains report number 3. Therefore, only one report is included in the list of parameters when the model is actually prompted. As a result, the total token count also exceeds 200,000, and additionally we may see that there is a cached token count that exceeds 100,000. The output of the model also contains a comparison of reports, one of which was cached when model was initialized, and the second served as an input when the model was prompted. For the second comparative analysis, another report is loaded and used as an input for a similar model request. In this case, the cached token count is exactly the same as in the previous request. However, the total count is less because the last report is less voluminous. And again, the model provides an output similar to what was shown before. It's a comparison of companies based on 2 reports. So this was a demonstration of a scenario in which a cached report was used in 2 consecutive model requests. In general, these 3 examples have shown how useful and handy LLM with a large context window may be for practical tasks in the financial sphere.